Welcome back. In this lecture you will learn how to ensure that the components of an HVAC system supply clean, draft and noise-free air to the designated spaces. Transportation of air takes place by the supply and/or return ducts. Those ducts are available in different shapes and various materials and can be insulated both internally and externally, depending on the application. From studies is found that both new and used ducts can pollute the passing air. New ducts processed with oil contain small amounts of processing oil residuals. This oil layer is very thin and invisible, but it emits an annoying odor. But newly installed ducts can also pollute the air through emissions of dust and dirt accumulated in the ducts during construction at the worksite, mostly inorganic substances. Then, when in operation, growth of microorganisms, emissions and organic dust accumulated in the ducts during operation can be sources of pollution as well. For ducts to ensure that they are able to supply clean air, it is therefore recommended to start with clean ducts, that is free from oil, residues and dust dirt accumulated during construction. This can, for example, be established by closing the end of the ducts at the construction site, as you can see here on the picture, and by cleaning all parts in contact with the airflow just before installation. Then it is recommended to select ducts with smooth inner surfaces, that is, avoid sharp-edged curves, turns, transition pieces or self-tapping screws in duct walls, because dirt can accumulate at such places. To prevent dust dirt to enter the ducts during operation, it is important to use an efficient filtering system. Furthermore, add insulation material to the outside of the duct, not on the inside, to prevent condensation on the inside and thus give microorganisms no chance. Also prevent condensation of water from humidifiers, and preferable, do not use sound attenuators. Those can become an important pollution source as well. When air is distributed through the ducts, depending on the air velocity in the duct, noise can be created, the so-called rustle of air. The smaller the diameter, the higher the velocity with the same airflow rate, the higher the sound level. Additionally, change of duct diameter along the way or direction of the airflow can cause a sound effect. To prevent noise annoyance from airflow in ducts, it is therefore recommended to have as less as possible changes in duct diameter or direction of the airflow. Moreover, it is recommended to keep the air velocity in the duct below 3 meters per second. For round ductwork, the equation shown here can be used to calculate the air velocity for a certain duct diameter and airflow rate. The supply to and exhaust of air in a space takes place through air grills. The location, the number, the type and settings of the grills depend on the selected ventilation principle and the required amount of ventilation. We know a number of grills that are available in various shapes and dimensions, such as line grills, whirl diffusers, ceiling, floor and wall grills, air valves and air distribution bags. The hole through which the air supply takes place is usually covered with a diffuser or grill. The direction and the throw of the air jet can be controlled by the position of the blades of the grill. And when the supply is just under the ceiling, the air will follow the ceiling, it sticks to the ceiling, resulting in the so-called Coanda effect. Mixing of the airflow occurs in this case only on one side. With an increasing turbulence, the rate at which the jet becomes thicker increases, as does the rate at which the velocity on the axis decreases, shorter throw. Because of this sticky effect, a wall jet will continue longer than a free jet, and will therefore enter the occupied zone later. However, this depends also on the temperature of the air supplied and the room air temperature, and thus the existing airflows. The supply of air into a space through a grill can cause draft when the supply air temperature, the setting of the blades and/or the air velocity are badly designed and/or set. According to the Dutch building decree, the supply of fresh air should not cause an air velocity larger than 0.2 meter per second in the occupied zone of an area where people stay. According to ASHRAE, the American Society for Heating, Refrigerating and Air Conditioning Engineers, if the operative temperature is higher than 23 degrees Celsius, the air velocity may increase, but may not be higher than 0.8 meter per second. The occupied zone is here defined as the space between the floor and 1.8 meter above the floor, and more than 1 meter from outside walls, windows or fixed HVAC equipment, and 0.3 meter from the internal walls. The feeling of draft is, however, not only influenced by the air velocity. It is also influenced by the turbulence, the standard deviation of the air velocity divided by the average air velocity, and the temperature. Therefore, the DR, the draft rating, has been introduced. With the DR approach, it is possible to predict the percentage of dissatisfied occupants resulting from draft, while accounting for the temperature, velocity, and the turbulence intensity locally. Now, for air supplied through a round opening, resulting in a free jet, the following equation can be used to calculate the velocity at distance x of the opening, assuming the temperature of the supplied air is equal to the room air temperature and there is no existing airflow in the room. The location where the air leaves the space has almost no effect on the airflow pattern. This is because during the exhaust of the air, the kinetic energy occurs in the return duct, while the airflow to the hole takes place from all directions in the space. The air velocity of the supply to the hole decreases in principle quadratic with the distance to the hole. Because it's beyond this course to exactly calculate which ventilation rate per grill is allowed, the following recommendations can be given in the case of mixing ventilation. First of all, limit the ventilation rate per grill to 10 liters per second. Second, locate the air supply grill as high as possible, but at least 1 meter 80 above the floor. If more than 10 to 15 liters per second per grill is supplied, take measures, such as locate air supply at a location where no occupants are present, locate air supply above a suspended ceiling, or provide air supply through an airflow guiding profile just below the ceiling. In summary, this lecture provided you with tips to ensure that air ducts and air grills together deliver clean and noise and draft-free air to the designated spaces. Thank you for your attention.